Hi everyone, good evening. Welcome to Belagali's classes. I am Professor B.M.Belagali, retired from RLS Institute, Belagavi. There I served nearly 30 years. Tuitions for both the colleges, especially RLS, JSS. I've engaged more than 40 years. I taught for even JSS students who attended my classes there in the batches, even for RLS and other colleges also. Yes, my friends. So, coming to the subject. So, many of your seniors, whether your sisters, brothers, anybody in the house, most of them, they know me, and they know my teaching. Basically, I go slow. I teach each and everything in detail. I do all examples from the textbook, question papers, even model question papers. And to begin with, I will start with inverse trigonometric functions, which is the basic that needs what? Even for your calculus, mainly for differentiation, even for integration, the properties of inverse trigonometric functions are needed. That's why, as a base, I first start with inverse trigonometric functions. Okay, I do it all 1 mark, 2 mark, 3 mark questions. Actually, in inverse trigonometric functions, trigonometric functions. In brief, my friends, I write it as what? I for inverse, T for trigonometric, F for functions, ITF. In this, you have one example under 1 mark and one example under 2 mark and one example under 3 mark. My friends, to the main exam, nearly you get what? 6 marks. 3 plus 2 plus 1. Even in CET, you have minimum 1, maximum 2 examples. 1 or 2 examples in CET. Correct? Friends, this chapter is very simple. It becomes more simple and easy if you know the basics, that too about trigonometric ratios or trigonometric functions. Then I give what do you mean by inverse of a function or inverse of a trigonometric function. This I give little detail instead of giving directly the definition of what. There are 6 inverse trigonometric functions, definition of sine inverse, this, that. While defining, you get what? 1. Restricted domain, restricted range. Why the domain of those functions are restricted? Cut. I will explain that in 1 minute, my friends. Before that, just I will explain a little about the trigonometric functions. Later, I will explain about inverse of a function. Then I will come to inverse trigonometric functions. These divided into 3 parts. Yes, my friends. Connected with trigonometric ratios. Here itself in the side you are observing. Trigonometry always moves with a right angle triangle consisting of a what? Acute angle theta. Everything I have written brief. If it is theta, what is this, my friends? It is a side which is opposite to theta. I have written in brief O, opposite side. What is this, my friends? It is a side which is adjacent to theta. Written as or called as adjacent side. I have written in brief, capital A. My friends, what is this? It is right angle A side which is opposite to the right angle is hypotenuse. I have written in brief H. So it is what? Right angle triangle in which acute angle is theta. A side opposite side O. A side adjacent to theta A, which is opposite to 90, name is hypotenuse. With the help of these three sides, first ratio sine theta, opposite side upon hypotenuse, I have written in brief O by H. What is cosec? Reciprocal of sine, 1 by sine, that I have written, go to the down. What is cosec? Hypotenuse upon opposite side. I have written both, sine from up to down, cosec from down to up. What is sine? Opposite upon hypotenuse. What is cosec? Hypotenuse upon opposite. On the same way, what is this? Cos theta, adjacent side upon hypotenuse. What is sec? Reciprocal of cos. Yes, what is the definition? Hypotenuse upon adjacent side. Tan, opposite upon adjacent, cot, reverse it. This is adjacent upon opposite side. That itself tells everything. What is cosec? 1 by sine. What is sec? 1 by cos. What is cot? 1 by tan. If you know, if you take what? Everything you know, just I write. What is it? Then sine theta upon cos theta is tan theta. My friends, it is tan theta. Then what is cot theta? It is cos theta upon sine theta is cot theta. These five known as reciprocal identities, my friends. With the help of this right angle triangle, using the great man, Mr. Pythagoras, using his theorem, we get the identities, what they are. Sine square plus cos square is 1. 1 plus tan square is sec square. 1 plus cot square is cosec square. It is an identity theorem that we can prove with the help of what? Using Pythagoras theorem. What is it? Sine square theta plus cos square theta is 1. 1 plus tan square is sec square theta. 1 plus cot square is cosec square theta. These are identities. My friends, these are connected with usual trigonometry. These are known as, the 6 ratios are known as 6 trigonometric ratios. 6 trigonometric ratios, and they are also called as trigonometric functions. Yes, my friends. But here, for the second year, while doing inverse trigonometric functions, the part we want for inverse trigonometry is values of trigonometric ratios. Values of trigonometric ratios, I write in brief. Trigonometric ratios of standard angles. Standard angles. What are the standard angles? Friends, 0, 30 degrees, 45 degrees, 60 degrees, 90 degrees. More than 90 degrees comes under allied angle formula. Okay. This list is very important. You must copy it, because while writing the values of inverse trigonometric functions, we need it. This is trigonometric ratios. Trigonometric ratios. I write mainly 3. One is sine. Second is cos. Third is tan. This is third. I write here the angles. 0 degree. This is 0 degree. Then I write 30 degrees, or pi by 6 radians. This is second. The third is 45 degrees, or in terms of radians, pi by 4. Next is 60 degrees, or it is pi by 3 radians. And 90 degrees, or it is pi by 2 radians. 0, for the 0. Yes, sine 0 is 0 and cos 0 is 1, tan 0 is 0. See my friends, actually if I write only these two, you can write the remaining. This is 0 by 1, 0. Tan 0 by 1 is 0, is correct. Then comes 30. Sine 30 is 1 by 2. Cos 30, root 3 by 2. Tell my friends, what is this upon this? 2 cancels, it is 1 by root 3, tan 30. Then comes 45 degrees. Sine 45, 1 by root 2. Cos 45, 1 by root 2. Tell my friends, here this itself a division sign. This divided by this is 1. Then 60, cos 60 is 1 by 2. Sine 60, my friends, root 3 by 2. Cos 60 is 1 by 2. Tell, what is tan 60? Root 3 by 2 upon 1 by 2. Reciprocal, this 2 cancels. So, tan 60 is root 3. Then, about the 90. Sine 90 is 1. Cos 90 is 0. 1 by 0 is what? Not defined. Undefined. It is a infinity. It is undefined. Yes, my friends. Automatically, the remaining 3, just I tell 1. Next comes cosec. Yes, my friend. What is cosec? 1 by 0. Not defined. I write ND. Not defined. Then, what about sine 30? Reciprocal 2 by 1. What about cosec 45? Reciprocal of this, which is root 2. Yes, friend. Then cosec 60. What is cosec 60? Reciprocal of this, which is 2 by root 3. Then comes cosec 90. What is the reciprocal of 1? Is 1. Like this, my friends, you can write sec, all these are reciprocals. Sec 0, 1. Sec 30, 2 by root 3. Sec 45, root 2. Sec 60, 2. Sec 0, undefined. Why? It becomes 1 by 0, not defined. Last is cot. My friend, cot with tan. What is cot 0? Reciprocal 1 by 0, which is not defined or undefined. Then cot 30, reciprocal root 3. Cot 45, reciprocal 1. Cot 60, reciprocal 1 by root 3. And what about cot 90? What is cot 90? 0 by 1, which is 0. Yes, my friends. This is the list, this is the table that gives the values of all trigonometric ratios of standard angles. This is up to 90. Up to 90, I will explain what is allied angle rule. Directly I will give the rule because it is useful while showing the functions where it is 1 function, where it is not 1 function. My friends, just this is allied angle formula. Allied angle formula. Yes, my friend. Allied angle formula means it is a trigonometric ratio of allied angle. What is allied angle? It is n into 90 degrees plus or minus theta, my friends. Why? If n is 1, pi by 2 plus theta. Or pi by 2 minus theta. If n is 2, pi plus or minus theta. If n is 3, 3 into pi by 2 plus or minus theta. That goes list. big list. It is a infinite set. This allied angle we write in brief as what? N into pi by 2 plus minus theta. Plus minus theta. What about this? N is a positive integer. Positive integer. Alright. Yes, my friends. This equal to, you get what? This value in RHS depends upon N. So what do you mean by that? What N can take the values? N can take either positive values. N is positive means what? It is a even values. N is even, N is odd. If N is even, trigonometric ratio in LHS, it remains as it is. Trigonometric ratio, if N is even, trigonometric ratio in LHS remains as it is. For example, if it is sine, it remains sine. Cos, cos. Tan, tan. No change in this case. What is it? Trigonometric ratios of theta. If N is even. Then what is second case? If N is odd. If N is odd. See friends, when N is odd, trigonometric ratio in LHS changes to co-trigonometric ratio of theta. Changes to co-trigonometric ratio of theta. What is this? What are the co-trigonometric ratios? My friends, here, this sine and cos are co-trigonometric ratios. One pair. Co-trigonometric ratio of sine is cos, cos is sine. What is third? Tan and cot. This. Co-trigonometric ratio of tan is cot, cot is tan. Second pair. What is third? Co-trigonometric ratio of sec is cosec, cosec is sec. These three pairs. My friends, if it is odd, if it is sine here, that sine changes to cos. If it is cosec here, that cosec changes to sec. That changes between only what? Co-trigonometric ratios. Three pairs. Sine cos, tan cot, sec cosec. These are three pairs of co-trigonometric ratios to one another. Yes, my friends, I hope it is clear. This is one. One thing you must take care, whether it is plus or minus, it is always plus. Remember, my friends, sometimes the students will go little wrong assumption. If it is plus here, they write plus here. If it is minus here, they write minus. No. Even if it is plus minus, but you have to take only plus sign. Trigonometric ratio of plus theta only. I repeat once again, my friends, trigonometric ratio in general, allied angle, comes under two cases. N is even, N is odd. If this N, which is a coefficient of pi by 2, this N, if it is even, trigonometric ratios in LHS remains as it is. If N is odd, trigonometric ratio in LHS changes to its co-trigonometric ratio. This is first rule. What is second? Attach the sign. Attach the sign using quadrant rule. I write simply Q. Quadrant rule, namely first quadrant all positive, second quadrant sine positive, third quadrant tan positive, fourth quadrant cos positive. ASTC, or all silver teacups. Now I can't tell. When you joined first year, at that time you used to remember after school to college. Now it is no, you are moving from first year to second year in the same campus. So you remember all silver teacups. My friends, this is called as allied angle formula. Allied angle formula. By making use of this map, I wanted one value or two values connected with sine. My friend, I want to find the value of sine 150 degrees. I want to find the value of sine 150 degrees. The sine 150 you divide by 90 degrees. This you can write it as what? 1 into 90 degrees plus 60. This 150 back. Now 1 means what? It is an odd number. Odd number, sign changes to cos of 60 degrees. What about the sign here? What is your trigonometric ratios? Sign. In the second quadrant, sign is positive. See my friends, what is this? 90 plus 60. 90 plus 60 means 1 plus. It is in the second quadrant. Second quadrant. In the second quadrant, sign is positive. Therefore, the sign here is positive. What is the value of cos 60? My friend, cos 60 is 1 by 2. I go with one more. What is that? Sine 390 degrees. What is it? Sine 360 plus 30. Is it correct? That 360 I write it as what? Sine 4 into 90, 360 plus 30. Plus 30. My friends, apply that side rule. What is the coefficient of 90? 4. What is it? It is an even number. When n is even, no change. Whatever you have in LHS will continue in RHS. Yes, my friend. In LHS you have sine. This is 30 degrees. What about the sine? 4 plus means 4 plus 1 is 5 here. See, 4. 1, 2, 3, 4. Plus means it is in the first quadrant. In the first quadrant, all positive. Then sine is positive. Then what is its value? 1 by 2. 1 by 2. Why I am giving all these things, my friends? See, what I wanted here is, for the same RHS, what is the RHS? 1 by 2. Here it is, RHS is 1 by 2. See here, 1 by 2. Even sine 30, 1 by 2. 1 by 2, 1 by 2, 1 by 2. In case of trigonometric functions, the same value between minus 1 plus 1, there exists infinitely many values. I just referred with only 3 here. 1, this is second, this is third. Like this, my friends. Next, this is 1 round. This is 360. If I move with the second round, what is it? 2 into 360. 3 into 360. 4 into 360 plus 30. Infinitely for same value. 1 by 2. 1 by 2. There exist what? Infinitely many angles. First is 30. This is 150 degrees. This is 390. What is next? 2 into 360 plus 30. That is something, 700 something. Okay, like that. There exist, my friends, infinitely many values. Please remember this one. What is that? Corresponding to one value in RHS. What is that one value? 1 by 2. 1 by 2 in RHS. In case of sine, I have taken one trigonometric function, one trigonometric ratios. Corresponding to the sine, there exist infinitely many values of theta. Infinitely many values of theta, angle. Many values of theta. Remember, my friends, this is one. Like that in case of what? Cos. Same thing I can explain. Tan means in case of all 6 trigonometric functions, for corresponding to one value, one real number, that is 1 by 2 or 1 by root 2 or root 3 by 2 or 1 or 0, anything. This shows there exist infinitely many angles. Many angles. This you can represent graphically or with a relation of function. Relation of function. My friends, 1 minute, see. Just to remember it. Yes, my friends. Next, this is trigonometric functions. I explained up to 1. Now I take only function. Only function. Yes, my friend. You know the definition. What is it? There are two sets. What is it? It is a set A. It is set B. My friends, this is called as domain of the function. This is codomain of the function. These are the elements of domain 1, 2, 3. These are what? Elements of the set B, that is codomain. Then this is the function f. It is a correspondence between two sets. It associates an element of the set A, a unique element of the set B, unique element. The same one, if it takes B, it is not a function. It will take only one. But this is allowed. This is allowed. Which is allowed? Second element can take what? One. This is allowed. Even all the three elements can have only one friend, A. But one element can't have more than one. That is a unique. That is a unique. My friend, this is function. While explaining this function in the PUC first year, even this year also you have again functions. You have the types, namely 1 function and onto function. These are the main two. I will explain these two. We want it. What is 1 function? This is 1 function. Yes. Elements of the set A, different elements of the set A, if they have different images. I use locally the word friend. This friend has 1, second, third. What is your observations? Different persons have different friends. This is known as 1 function. Then what is onto function? Onto, right from B to A. Yes. What is your observation? All the elements of B have some friend in the set A. If any element left here, D, this D of B doesn't have any friend where in the set A. In that case, it is not onto function. When it is onto, all the elements of codomain or codomain should have at least one image where in the set A. In that case, this function f is said to be onto function. In this case, when this function is said to be what? Both 1 and onto. Both 1 and onto. If a function is both 1 and onto, then that function is called as bijective function or bijective mapping. This definition is very much essential for what? Inverse of a function first. Inverse of a function. Inverse of a function exists if the function f is both 1 and onto. If the function is both 1 and onto. What is 1? Different elements of A should have different image. By chance, my friend, if it is a friend of what? B. If it is a friend of B, in this case, the function f is not 1. When it is 1, different elements should have different images, different friends in the second set. This, my friends, this is 1. So, for the basic definition for what? Existence of inverse function, the function must be both 1 and onto. Both 1 and onto. Yes, my friends, this is definition of 1 onto. Inverse exists when the function is both 1 and onto. Yes, this is about this function. Finally, I will come to what? Inverse trigonometric functions. Finally, this entire definition. Yes, my friends. Then, inverse of a trigonometric function. I take, for example, your fx is sin x. Your fx is sin x. Yes, my friend. The inverse of a sine, the inverse of a sine function, the inverse of sine x exists only when function means sine x. Function sine x is both 1 1 and onto. Both 1 1 and onto. Tell my friends, I told here, what is it? I just explained with sine. For sine x, this is the domain of sine x. Domain of sine x means you can take any angles. My friend, it is 30 degrees, 150 degrees, this is 390 degrees, like that it comes. Here in the set B, set A, set B, I take the values like 1, 1 by 2, 1 by root 2, like this. Tell, what is sine 30? Is 1 by 2. What is sine 150? I told 150. What is sine 390? It is also what? 1 by 2. 1 by 2. Tell my friends, sine is a 1 1 function. Figures are there, I have explained here. This is both 1 1 and onto function. And inverse of a function exists only when if the function f is both 1 1 and onto. This is your sine. You are studying what? Inverse trigonometric function. We are going to study the definition of what? Inverse of sine x, inverse of cos x, inverse of tan x, like that. First itself, it is sine x. This is its graph. For different angles, there exists only one value between -1 and +1. Between -1 and +1. See my friends, is sine a 1 1 function? Is it a 1 1 function? These are different, but in B there is only one. When is 1 1? This 30, 150, 390, they must have what? Different images in this. But what it shows, all the three have same image, which is 1 by 2. When it is 1 1, 30 should be 1, 150 should be another, 390 should be third. They must have different values in the second set in the codomain. But what happens here? All the three have only one. It is a value between -1 and +1. Then when you call it as 1 1, you have to restrict to the small angle. What is the least angle among the three? Is a 30 degrees. If you restrict to the 30, what is sine 30? 1 by 2. So, to make sine function, my friends, 1 1, we are restricting the domain of sine x to where? 30 degrees. What is the 30 degrees? It is an angle between 0 and 90 degrees. Like that, for negative values. If it is -1 by 2, what is the angle? -30. Is it so? If it is -half, -30. If it is +half, +30. Then what about 30 and -30? They are the angles between -90 and +90. This -90 and +90, it is the domain of what? Sin x. When sin x is a 1 1 function. 1 1 function. Understood? For the 1 1 function, we restrict the values, the angles of what? Sin to only 30, otherwise -30. And it is a value between, where, my friends, -π/2 and +π/2. -90 to +90. We restrict the angle in case of sine to where? -90 to +90. This is known as domain of sin x. Domain of sin x. In this case, the sine function is 1 1. Then what about its range here. The values are restricted between where? -1 to +1. Tell why? My friend, sine of -90. What is sine of -90? Sine of minus theta is minus sine theta. Sine of -90 is minus 90 degrees. What is sine 90? Sine 90 is 1. So it is minus minus plus plus. Therefore, this is known as domain of sin x. This is known as range of sin x. From this it is clear, inverse of a sin x exists only when if you restrict the domain and range of sin x. Otherwise, if we leave free for all, no. Why? All these three take the value 1 by 2. In that case, the sine function, it is not 1 function. Therefore, to make the sine 1 function, we are restricting the domain to where? Minus 90 to plus 90, or minus pi by 2 to plus pi by 2. Therefore, my friends, the inverse of a sine exists only when if x takes the values between minus 90 to plus 90, and if you take this equal to y, then y takes the values between minus 1 to plus 1. Put sine x equal to 30 degrees. What is sine 30? 1 by 2. Understood? You can't take y restricted. This 150 is an angle outside 90, not permissible. For an inverse function, these are not permitted values of angle. Therefore, my friends, through this I want to convince what? Inverse of a trigonometric functions exist under the condition, under the restricted domain and range. This is for the sine. This is domain, restricted domain, minus 90 to plus 90. This is range for sine. For the inverse, when it changes, this becomes the domain, this becomes the range. My friend, today I will explain only one inverse of a sin x. In the next video, I will explain with the remaining. Yes, my friends. Alright, I think it is clear why we are writing the restricted domain and restricted range. Only because of that. In that restriction, in that compound, we define the inverse trigonometric functions. For all angles, we can't define, we can't write what? We can't define what? Inverse trigonometric functions. Therefore, inverse of trigonometric functions exist under restricted domains and range. I hope it is clear, my friends. Okay? Yes, my friend, I write today one definition. Yes, my friend, definition of a sine inverse. Yes. Definition. Inverse of a sin x. Inverse of a sin x. Inverse of a sin x is denoted. Inverse of a sin x is denoted as, yes, like that man. What is it? Sine inverse of x. Inverse of a sin x is denoted as sine inverse x and is defined as follows. Defined as follows. friends, if y equal to sin x, where comes, my friends, that condition. What is the condition? Find sin inverse y equal to x. Now, my friends, I do one change here. Instead of y equal to sin x, I take x equal to sin theta. Yes, it is proper. Where theta takes the values between minus 90 and plus 90. And x takes the values between minus 1 and plus 1. X takes the values between minus 1 and plus 1. Then we define sin inverse x equal to theta. See, my friends, what is done? This x equal to sin theta is written as sin inverse x equal to theta. What is done? Sin of RHS is taken to LHS. That sin takes sin inverse or inverse of sin. Yes, my friends, if x equal to sin theta, under this condition, what is this condition? This angle must be between minus 90 plus 90. What about this LHS number? It must be between minus 1 plus 1. If these two holds good, correct, then this sin theta becomes sin inverse x equal to theta. You can take what this sin this side, that becomes sin inverse. Under this condition, if this condition is not correct, not true, this sign doesn't come to this side. Under this condition only that sign comes, because inverse, for the inverse we need what? The function must be both 1 1 and R2. When it is 1 1, if you restrict the values of the angles to 30, that is between minus 90 plus 90, then only the function sin x is 1 1. Then we can define its inverse. What is the inverse of sin? Sin inverse, like this man, you know already. If it is a number a, what is its inverse? We are writing minus 1. On the same lines, sin inverse, we are writing that minus 1 here. Yes, my friends, from this what is clear? Therefore, sin inverse x is an angle theta, where these two, whose sin of theta must be x. So from this, therefore, sin inverse x is an angle theta, where minus 90 less or equal to theta, less or equal to plus pi by 2, and minus 1 less or equal to x, less or equal to plus 1. Sin inverse x is an angle theta, where this such that sin of theta is x. Sin of theta is x. Therefore, my friends, you know, what is sin 30 degrees? Sin 30 is 1 by 10. What about this 30? It is between minus 90 plus 90. What about 1 by 2? It is between minus 1 and plus 1. Therefore, by definition, 30 degrees is sin inverse 1 by 2. Sin inverse 1 by 2. Under this condition, you can take the sine to this side. The sine becomes sin inverse. Therefore, sin inverse half is 30 degrees from this man. That is, sin inverse half is 30 degrees. Tell my friends, what is this? Angle corresponding to 1 by 2. Similarly, sin 1 by root 2. Tell my friends, it is an angle whose sine is 1 by root 2. Means corresponding angle. What is the corresponding angle? 45 degrees. sine inverse root 3 by 2. What is this? Corresponding angle, that is 60 degrees. And sine inverse 1. 1 is what? Sine 90 is 1, 90 degrees. Sine inverse 0. Sine 0 is 0. Therefore, sine inverse 0 is 0. Like that, my friends, making use of this definition, inverse of a trigonometric first one, that is inverse of sine x, denoted as sine inverse x, exists. This is the definition. These are corresponding values. My friends, sine inverse 1 by 2, corresponding angle, 1 by root 2 in case of sine, corresponding angle like this, my friends. This is about sine inverse x. Similarly, the other inverse trigonometric functions are cos inverse x, tan inverse x, cosec inverse x, sec inverse x, and cot inverse x. Mainly, we have an interest for 3, or they are sine inverse, cos inverse, tan inverse. Other 3, making use of the properties that cosec inverse can be converted in terms of sine inverse, sec inverse in terms of cos inverse, cot inverse in terms of tan inverse. So whatever you have done for this are useful for this. Yes, friends, tomorrow in the next class I do what? Remaining inverse trigonometric functions. Is correct? Yes, friends. Thank you very much. If any mistakes, if any corrections, anything you needed, please either phone, otherwise message. You do it.